Hello, welcome back to Cracking the Cryptic and, well, another puzzle by Ard von der Wetering today, which I'm really looking forward to because Ard always comes up with something pretty interesting. We'll get to that in a moment. Now, in just, 4 days' time, it's going to be our new puzzle hunt, Quite Approachable Sudoku. We're really looking forward to bringing that to you. Do consider joining our Patreon to be in with a chance of having a go at that. You'll get 20 days to do basically 7 puzzles that are quite approachable. Some of them might verge on genuinely approachable, some of them a little harder, but I think you'll really enjoy having a go at those in the standard variants that have been the basis of our apps, basically. So that should be good. We've also, on Patreon as well, today I have posted a video of me solving a Fistemafel puzzle. Now, you are used to seeing Simon solving Fistemafel, but I found out this 6x6 puzzle had been posted today on Logic Masters Germany, and I've nipped in there and done it before Simon could. So that's on Patreon. It's not the hardest Fistemafel ever, but it's quite interesting. Do have a look if you get the chance. It wasn't really long enough to be one of our regular videos, I'm afraid, but it's an interesting puzzle. Now, what else have we got going on? Well, I mean, so much stuff, but do check out the links under the video for all our apps and our merchandise, Sven's SUDOKU PAD. Everything about the channel is there, basically, and the first link is to this puzzle by Ard. It's called Anti-4. Normal Sudoku rules apply. No two orthogonal neighbours can sum to 4 or a multiple of 4. That's in the whole puzzle. So these two cells could not be, for instance, a 1-3 pair or a 9-7 pair, because those would add up to 4 or 16. And you can't have any pair of cells that are connected by an edge adding up to 4, 8, 12 or 16 in this puzzle. Now, any line in the grid, and you'll see there are 3, I've given them different colours so we can see they're different lines, has a sequence of consecutive digits, not in any particular order, sometimes called Renban, and that means that along this line, for instance, these are 3 consecutive digits, although they could go 4, 2, 3, for instance, or they could go 8, 7, 9, as far as I can see. We don't know the order, but we do know they will be a series of consecutive digits. The same is true for the yellow and the purple lines. Do give it a try. That's all we get, 5 given digits, and this painted 4 in the anti-4 grid. But give it a try. Ard's puzzles are very rewarding. I'm going to start now. Let's get cracking. Well, it's a weird sort of negative constraint, this, about the orthogonal neighbours. Let's look at this purple line, because it's in a column with a 7 in it. So if that's a sequence of 4 consecutive digits, they can't involve 7 or 8 or 9, which would be shut out. So they must have a 3 and a 4 in. They're either 1, 2, 3, 4, 2, 3, 4, 5, or 3, 4, 5, 6, I reckon. Now, does that have an impact here? This couldn't be more, because one of the digits is shared with the grey line. That couldn't be more than 4, 5, 6. But then that could take us... Well, actually, no, it goes through that. I don't think we could end up with a 9 on any of the lines, but... Oh, okay, that's worth knowing, because actually, that's going to give me a 9 in the central box. Is that right? I want to just check. If you had a 9 on this line... First of all, I was worried that if this was 3, 4, 5... Oh no, I was thinking if this was 1, 2, 3, 4, then the most this could be is 4, 5, 6. And that would allow theoretically 6, 7, 8, 9 here. But actually, since it crossed through that, you couldn't get up to 9. But I'm talking absolute bobbinsy nonsense, because this doesn't have to be 1, 2, 3, 4. This could be 3, 4, 5, 6. This could be 6, 7, 8, and then you can get to 9 easily. So I've just... yeah, you could get... No, okay, I'm going to stick with it. I'm going to stick with it after all. Sorry, I keep going back and forwards on this theory. Those can't have a 9 on because they've got a 3 and a 4 on and they're a sequence. The most this could be is 6 accordingly, 3, 4, 5, 6, and then this line can't have a 9 on it. And that means this cell is not a 9, those cells are not 9s, these cells are all not 9s because of the given 9, and this is not a 9 because those two cells would then add up to 16. So we can place 9 in the central box. Ha, that's my first digit. Now, what else can we place? Look at 7. 7 can't go next to either 1 or 9, or 5 actually. Yeah, I think each digit has some other digits of the same parity which it can't neighbour in this. So anyway, 7 can't be in those cells by virtue of the given 7s, and it can't be next to 1 because that would make 8. So 7 has to be here. Now we do know something about the yellow line. It's got a 7 on it. So it must have a 6 on it somewhere as well. That annoyingly could be on the purple line too. Okay, let's think about other digits though, because 5 can't go next to 1 or 9. No, that's wrong. I've got that wrong, sorry. 5 can't go next to 7 or 3, in fact. I got it entirely wrong. Right. Oh, nearly right, nearly. 5 can't be next to 7, so it can't be in any of those cells. So the 5 in this box is in one of those two. What about 3, which can't go next to 1 or 9 because it would make 4 or 12? So 3 is definitely in this column, so neither of these can be a 3. That's a surprising conclusion. Oh, and look, 9. 9 can be placed in column 6. There's a 9 here and a 9 here. There's got to be a 9 here. There's no way it's on this Renban line which has got a 3 and a 4 on it. They can't reach to 9. So 9's at the top there. 7 is in one of those cells just by Sudoku. What can't be next to 9? 3 can't be. And 7. Oh, 7 in row 5. Look at that. Those two 7s are telling us 7 is in one of those two cells, but it can't go next to 1 because that makes 8. So 7 can be placed there as well. It probably doesn't get anything else done. I suppose 9 also can't be in those cells, but it can still be in any of these. Yeah, this is quite fiddly in a way. You have to ask yourselves the right question all the time. Maybe we keep focusing on odd digits. Right, 1 can't be in those cells in box 8, and it can't go next to 7. So it must be in one of these two. 3 is definitely in one of those two cells now, because it must appear on this line, and we worked out it couldn't be up here. Oh, and 3 can't be next to 5, so we couldn't put 5 here. Or 3 would be here, and they'd add up to 8, which is a multiple of 4, so that's not a 5, so 5 does go in here. Okay, now 5 can't be there, and it can't be there. Is 5... Oh, I wish I knew if 5 was on the line. The line could still be 1, 2, 3, 4. In which case, the 1 and the 3 would have to be separate. So 1 would have to be up here. 3 would be down here. No, I don't know. What was I going to look at next? I've looked at 5 down here. I haven't really looked at 1. Yes, I have. I've filled in the 1 possibilities. Five. No, 5 in that row is not very helpful. That can still be a 5, can't it? It's not prevented. Yeah, this is the sort of puzzle where you are going to be spotting things quicker than me a lot of the time, because I can only focus on so much. Oh, I'll tell you what, this can't be a 3. We got 3 down to those two cells, but this can't be a 3 because this is a Renban line and 3 is too far away from 7. Oh, so 3 goes here. Now, that can't be next to 5. I still don't know anything about the rest of the constituents on the Renban line. Now this one though, I can't get a 3 or a 5 in the box. It's got to have a 6 on the line. If this was a 5, this could be a 6-4. If it was a 9, this could be 6-8 in the box. This can't be 4, so 4's in one of those 2 cells. I'm going to pencil mark a 4 in there. So this is, no, I was going to say this is 2 or 8, but actually 6 could be off the line. No, actually this couldn't be 6, because the only way of making up this line, this yellow line then, would be with 8, 9 as a pair, which is impossible, or including a 5, which is also impossible. So that's not 6. There is a 6 on this line, and it's in one of those cells. So this is 2 or 8. I don't think there's a way of me telling which. If that's not 8, 8 is on the line along with 6, but that's very feasible. I think I'm not using the anti-4 rule enough. I should be doing something else with that. Ah, yes, 3 can't be next to 9 because that adds up to 12. So 3 down here is not in those cells or any of these, and it's not next to that 9, so it's placed down there. Then we get a 3 in one of these 3 cells. 7, 3, 4, 9. What about 1? Now 1 can't be next to 3, so if it's in those cells, 1 and 3 form a triple. If it's in these cells, then on this line we've got 1, 4, 3, that'll be a 2. This can't be a 2, not on a Renban line with a 7. So 1 can't be in those cells, it is in these 3, and it is 1 and 3 can't be next to each other, so they form a pair in those 2 cells. That's very clever, that's really quite wacky. Now this is not a 1, 2, 3, 4 line, it can't have a 1 on it anywhere, we've worked that out. So it's got a 5 on it, the 5 must be up in this box, because it can't be there. So it's got a 4 and a 5 on it, and it might have a 6, as far as I know at this point. That's not a 4-5 pair, because these pencil marked 4s go through those 3 cells. So it might be a 4-5 pair, but it doesn't have to be. 1, 3, 7, 5, 9. So we've got lots of odd digits placed in these. In fact, that stops this being a 1, and we've placed 1 at the bottom. Can we place 5? Can't be next to a 7. Can't be next to a 3. Yes, we can place 5 in the bottom box. And then 2, 4, 6, 8. They're fine to be next to any odd digit. That'll never give a multiple of 4. But we're a bit... Oh no, hang on. 7 can't be next to 1, but it can be next to 3. Now, can this be a 1? What? Yeah, no way. What would this be as a junction of a line involving a 1 and a line involving a 7? There is nothing. That has to be a 3. And in fact, even that's a bit restrictive. This has to be higher than 3, but not as high as 5. So that's a 4. It's got to be right. This is either a 2 or a 6. I don't think I know which. But interestingly, that means it's not 4 or 5, and they both have to be on the line. Oh no, it could be a 5. No, sorry, it has to be a 2 or a 5. That's not as interesting. 4, 9, 5, 3, 7. So 2, 6, 4 now. What can 4 not be next to? It can't be next to 8, so that's not an 8. Also, we know where 1 is, so that's not a 7. 7's in one of these 2. 8's somewhere up here. Come on, does that 4 not do anything? Yes, it takes 4 out of these 2 cells. Oh, I had 4 marked as only in those cells. I hope that was just a wrong understanding. I think it must have been. This logic is fine. 3 to connect to 7 must do it through 4. So this has to be a 6-5 pair, and we know which way round they go. Right, Renban is much easier than anti-4, if I would just remember it. This is now a 4-5 pair, and in fact that is on the Renban line with a 4, so we've got 5-4 there. This is a 2-8 pair. That's 2 or 8, in fact that's resolved by the given 8. That fixes this. Now we're flying, not really, but we're moving. That's the same 6 or 8 as that. 7 can still be an I. Now we've got 2, 6, 8 and 7 to place. Now one of those is a pair. 2 and 6 make 8. So neither of those can be in this cell, or they would be next to the other. So that has to be 7 or 8. Now let's look along the boxes. We've got a 5 goes in there, just Sudoku. This is a 4, 6, 9 triple, but 9 can't be next to 3 or next to 7, so the 9 is placed. Then there's an 8 up here somewhere, which couldn't be next to 4, but could be next to 6. 5, 9. There's a 9 up here that can't be next to 7, so it's in one of those cells. That's kind of petering out now. 2 can be next to 8. Oh, 1 can't be next to 7, so 1's up here with 8. Right, so this is a 2, 3, 9 set, but that's beautiful. 2, 3, 9 is good because 3 can't be next to 9, so they've got to be split up or chaperoned by a 2. That must be right. So there we go. This is a 1, 4, 6 triple. 1 can't be next to 7. 4 can't be next to 8, but I don't think I can do any more. Got 2 and 3 over here, but 3 can't be next to 9. That would make 12. Oh, it's so hard to keep track of these combinations to me. That doesn't resolve these. I don't see if these are resolved. Oh, no, I can't see that they are. Or those, or these. And the trouble is now, how do I get out of this plus shape of boxes? Let's just fill in the candidates here. Suppose, well, no, I'm not going to, because they could both be anything. No, that couldn't be 8, I suppose. So 2, 6 or 7 there, and this can't be 7, so 2, 6 or 8 there. Okay, there we go. I've done the candidates. But how do we move on? Gonna have. Ah, look, 9. 9 can't be there, and 9 can't be there. 9 also cannot be next to 7s, so it is at least restricted down to those cells. And then 9 must be in one of these. Is that? I don't know. That doesn't get much. Then 7 can't go in these cells because it would be next to 9, wherever 9 is in those. So that rules out 7 from all of these places. That's not actually that helpful. I thought that was going to be better. Oh, it's tricky. You're going to have to do stuff like this to find a way through. Oh, 5 can't be next to 3. Why have I not noticed that? There we go. So they're done. Right, so that's not 9. Now again, what can't be next to 9? It's 7 and 3 can't be next to 9. Okay. And 3 can't be next to 5. Perfect. So 3, well, not perfect, but useful. 3 can't be in those cells because it would be next to 9. Can't be there because it would be next to 5, and it can't be here because of these 3s. So it's in one of those 2. Now 5 can't be next to 3, so that's ruled out of all of these cells, I think. 1 can't be next to 3, that's ruled out of those. That's not quite, I don't know, I don't want to just mark ones in all of those. That's a lot of cells. Crikey, how are we going to find a way through? I suppose this can't be 5, 3, 9 or 2. It also can't be 8. No, it can't be 6 to be next to 2. That doesn't do it. Maybe it's got to be these corners, hasn't it? 9, 5, 3, 4. Also can't be 7. I don't know. This is tricky. I don't really understand how I mean, it must be to do with limiting numbers to certain places and then ruling out other numbers as a result. Unless I'm just missing some blatant combo like that I'm for some reason not able to visualize. I mean, there's every chance that you are screaming at me, why can't you see it? But I can't. Let's keep going though. Let's keep going and see what we can find. So the even numbers are much harder to do any work with. Let's keep trying the odds. We've got 3. Now 1, I was saying, couldn't be next to 5. No, couldn't be next to 3. So it's not in those 2 cells or those 3. So there is a 1 somewhere there. And what about 7? 7 could be anywhere in those cells. Maybe I could rule it out of something here. 7 can't be next to 9, and it mustn't be next to 1. Oh, so 1 can't be in those cells. No, that wouldn't necessarily be next to 7. That is not a fair conclusion. 1 can't be in those or those. Not getting this, am I? Is it a parity exercise? Like a square like that has to be even? I don't think it is. Maybe I am just missing some big relationship. That could be a 1. That's the only odd number it can be, but it's got no problem being any kind of even number. Maybe it was up here then. If that was 8, it's fine. It can be next to 6 or 2. Seven couldn't be next to 1. Crumbs, I'm not seeing this. 3, 5, 9. 2 has to be in a corner somewhere. That's just not interesting enough. Oh, 3 can't be next to 5. So if 3 was there, 5 would be there to avoid that happening. 9 would have to be there. 7, no, it's 3 that's there. So 1 couldn't be next to 3. 1 would have to be there. Wow, and 7 would have to be there. I mean, it's possible. It's convoluted, but it does work potentially. Oh, excuse me 1 second. Right, sorry about that. So I was just looking at this corner where I'd made an assumption that filled all of these highlighted cells with odd digits. Now what was that? Oh, it was putting 3 in the middle. Yes, I'll just show you this again. So 3 in the middle, 3 has 2 possible places. If 3 was there, that forces 5 there and 9 there. Now 1 can't be next to 3, so that would have to go here. And then 7, which can't be next to either 1 or 5, if my maths is right, would have to be here. And this is an impossible configuration of the odd digits, actually, Because of 2. 2. Look at these given 2s. 2 needs to be in a corner here somewhere. So you can't put all the odd digits in the corners. And therefore, I have no idea if this is on the actual solve path or not, but it's a fascinating thing. And that means this can't be 3. And we get to place 3. I'm not sure that's going to do much. Oh, hang on. It puts 3 in one of those cells. No, come on. So that can't be next to 1 there. So 1 can't be in those cells, or that one, or any of those. So 1 is in one of these. Come on. 1 can't be here next to 3. It is in a pair with 9 there now, which is weird. We haven't learned where 2 goes. 7 can't be next to 5. No, hang on. 7 by Sudoku can't be in those cells. Oh, 3 looking up is in one of those 2. It can't be next to 1 or 9. So 9, which also can't be in those cells, now can't be in that because it would be next to 3. It can't be there. 9 is forced into one of those 2. What about 1? That also can't be there, or those, or that, because it would be next to 3. That's less good. Oh, come on. 7? 7 can't be there by just Sudoku. It can't be there because it would be next to a 9 in whatever position 9 is in. It's not helpful. 7 down here can't be in those cells. I've been looking at this, haven't I? I don't know what that means. Okay, let's have a look over here. Where's 5? How about that? 5 can't be there or there by Sudoku. It can't be in the middle of, I was going to say in the middle of 7s, but it doesn't have to be. Can't be next to 3. No, I don't know. This is definitely even. There's no odd digit it can be. Oh yeah, it sees, straightforwardly it sees 1, 9, 5, 7 and 3, so it's definitely even. How are we meant to do this? If that was 1, that would be 9. That's not a problem. Still need to wrap a cold towel around to make progress here. Five is in one of those. 5 can't touch 7, but it doesn't have to. Oh, what is going on? 9 is in that area. And those, and down here. Ah, yes, in one of those 2, isn't it? It doesn't resolve. 9 there would put 7 in one of those 2. 9 there would put 7 in one of those 2. Could that be 7? 7 is quite restricted down here. I can't see why not. Maybe this 3 and 9 stuff up here. 1 we've worked out can't be in those. I've looked at that. 5 can't be in those, and it can't be next to 3. So it also can't be there because it would be next to 3. So we're left with 5 in one of those two positions. And if 5 was here, that would push 3 and 9 into those cells, because they couldn't be next to 5. And that would put 3 and 9 next to each other, which would make 12. So 5 can't be here. Good grief, that works. Okay, so 5 is here, and that forces 3 and 9 to be in those positions. And now we've got some numbers apart from that one in the corner boxes. So 1 and 9 are done there. 1 can't be next to 3 here, so it's in one of those two cells. 6 and 10 are okay totals, annoyingly. So that's not a 1, and we've got 1 in this box. Now 4, 6 and 7. 7 can't be next to 9 in the column, so 7 is there. 4 and 6 I can't do much about resolving at the moment. 5 can't be next to 7, so it's there. All the odd digits are placed. Now, what about 7 up at the top? Can't be next to 1, so it's got to stay separate from it. 7 and 1 get placed like that. Very surprising arrangement. Right, there's a 9 now in one of those two. There's a 3 in one of those two. 5 is in one of those. 1 somewhere along there, but it can't be next to 3, so they've got to be separated by an empty cell. Right, that lets me fill in 1 and 3. 3 can't be next to 5. 7 in the box is in one of those, can't be next to 1, so 7 is there and can't be next to 9. So we're getting this kind of pattern again, twisted a bit there. Now that's placed 7 there, can't be next to 1, so 1 is there. 3 has been done, surely 9, yes, 9 has been done too, and 5 is here. And that must be all the odd digits in the puzzle. If I tidy up that box, they're all done. No, up here, 7. There it is. Right. So let's remove, oh sorry, I lost all my pencil marks. Could that be 8? I can't remember, I'm going to put it back in. No, it can't because it's next to a 4. Okay, so now it's just the evens to do. There could still be problems ahead. So where have we got, right. No, that can be 4 or, no, it can't be a 6. That has, because it's next to 2. So that has to be a 4. We get 6 there. That is 6 or 8. So we need to find places where evens end up next to evens across a box, I think. That, what about this? If it was a 6, it would be next to 4, that's fine. Ah, look, a 6, 8 pair in row 8. So that fixes 4, 6, 8. Oh, it's got 6, 8 pair down here. That's probably been available for a while. That becomes 6. That fixes the other pencil marks there. This is a 2 now. That's a 6. These pencil marks are not resolved, but all the others are. And that must be a naked single. 2, 4, 8 here, and 4 at the top. Yeah, that's okay. I thought I'd suddenly gone wrong in a cold, shivering fit of panic. 4 and 6 there. 2 and 8 down here. Oh, hang on. Got a deadly pattern left. Right, there's got to be an even number. There it is to sort out. Right, sorry, there's a deadly pattern there, an apparent deadly pattern of 2s and 8s. But thank goodness there is one number here next to one of those, so you can't allow those to add up to 8 or it would break the puzzle. That's a very neat finish to a very clever puzzle, as always, by Aud. And I hope I haven't made a mistake and left a pair in the grid that add up to an even number. I don't think I have, but wow, that's really interesting. I mean, it's quite, I don't know, attritional is the word I'm going to use. That's quite tough to do that, but very rewarding. Hope you had a go. Thanks as always for watching the channel, and I hope to see you again soon. Bye for now.